All right, so last lesson of the week. We are going to lesson 10 of Algebra 1, Unit 7. Again, we are bouncing around this unit as kind of a precursor to Unit 2 to help us get ready for Unit 2. And basically, the purpose of today's lesson is just kind of a wrap up of what we've learned this week. We've already talked about how to solve quadratics by square rooting. We talked about converting to factored form. We talked about the difference of perfect squares. And then we also can graph on Desmos. So we could also solve quadratics by using Desmos, by graphing on Desmos. And I will show everyone how to do that with the examples. So with that in mind, let's go to the examples. So an engineer is designing a fountain that shoots out drops of water. The nozzle from which the water is launched is 3 meters above the ground. It shoots out a drop of water at a vertical velocity of 9 meters per second. Function h models the height in meters of a drop of water t seconds after it is shot from the nozzle. The function is defined by h of t, I'm going to write it down here so it's a little bigger, equals negative 5t squared plus 9t plus 3. That's it. Okay. T squared plus 9t plus 3. Okay, how many seconds until the drop of water hits the ground? Write an equation that can be used to answer this question. So the good way of thinking about it is, what do I have to set this equation equal to? So negative 5t squared plus 9t plus 3. What do I have to set it equal to if I want to know how long? Again, t stands for time in this case. Think of t like x. But if I want to know how long it takes for the water to hit the ground, well, think about it. What is the height at ground level? The height is 0. So I need to set it equal to 0. Okay. Because of ground level. So for number 2, how many seconds until the drop of water reaches a height of 6 meters above the ground? Well, simply I could take the same equation. So negative 5t squared plus 9t plus 3. But instead of setting it equal to 0, I'll set it equal to 6. Okay. Number 3, same thing, except how many seconds until the drop of water reaches a height of 1 meter above the ground? So I'll take my equation and set it equal to 1. Okay, what do you think I'm going to do in number 4? Same thing, except I'm going to set it equal to negative 5t squared plus 9t plus 3, and I'm going to set that equal to 8. Okay. Pick one of the equations from the first 4 questions and solve it by graphing. In other words, use Desmos. So the cool thing about this is that we could go to Desmos. So I'm just going to type in the first one. Okay. So I'm going to, when I use Desmos, and this is really the only thing, is when I use Desmos, I'm going to replace the t's with x's. So instead of negative 5t squared, I'm going to put negative 5x squared. Okay, plus 9t. So in here, I'll do plus 9x plus 3. And if I put in equals 0, and I look at where the graph crosses the x-axis, I have the solutions. I could literally just click on the graph to get the solutions. Okay. Now in this case, we would want to know this was how long it takes for it to hit the ground. Now, obviously, a negative answer wouldn't make sense in this situation because that would be like saying the water hit the ground 0.287 seconds before it was launched. So it would take a little more than 2 seconds. Okay. And I could do the same thing with the other equations. So if I wanted to set it equal to 6, so I change that and set it equal to 6. Okay, and again, look at where the graph crosses the x-axis. Those are my two solutions. And I can do the same thing for the other two. So if I wanted to find how long until it reaches a height of 1 meter above the ground, okay, there we go. Okay, how long till it reaches a height of 8 meters above the ground? Okay. Notice in this case, there's no solution. It never crosses there's nothing there. Okay. So what do you think that means on number 4? That means it never actually reaches a height of 8 meters. Okay. So number 4 was kind of like a trick question. Now I know it only said to pick one of them. Okay, but I just did all of them really quick on Desmos. So you could see very easily you could solve any of these equations on Desmos. Now, with that being said, on your cooldown and on future quizzes and tests, if it says to solve it by converting to factored form, you need to solve it that way. You can't just use Desmos. If it doesn't specify what method to use, then you could use Desmos if you want. So if you look at your cooldown for tonight, lesson 10 cooldown, notice the first 2 questions, it says solve the following quadratic equations by graphing. So you can literally solve those by putting them in Desmos like I did. Okay. For 3, 4, and 5, notice it specifically says solve the following quadratic equations by converting to factored form and using the zero product property. So in that case, you either have to do the add multiply thing that we've been talking about, or the difference of perfect squares. You have to do it that way. Now, you could still use Desmos to check your work if you want, but you can't actually use Desmos as your main method of solving. Okay? So that is it for this lesson. Nice, quick lesson.